Welcome to Fairly Maths Academy. Today we are going to discuss on one of the 11 differentiation definitions and their proofs. Is the Newton quotient definition. It states that the function f is differentiable at x if the limit of f of x minus f of x, if the limit of f of x plus h minus f of x all over h is h tends to 0 exists. So we are saying if the limit there is h tends to 0 exists, then the function f is differentiable at x. So the value of the limit is denoted by df of x, and that df of x is the derivative of that function f of x. So let's have an example with our function f of x is equal to x squared. We want to find if the limit of f of x plus h minus f of x all over h is h tends to 0 exists. If the limit exists, then the function f of x is equal to x squared is differentiable at x. So to find if it is differentiable, we substitute our x there with x plus h, and this is our f of x and there is our h. So that's our limit of f of x plus h. We are substituting for x everywhere we have x, we are going to substitute that x with x plus h. So at x there we are substituting x plus h, then that x is squared. So this is now our x is squared minus our f of x there is x squared, so it's minus x squared all over h is h tends to 0. Then we simplify there, we get the limit of, we expand this part, it becomes x squared plus 2hx minus plus h squared minus x squared all over h is h tends to 0. Then we further simplify. We further simplify the we have the limit of x squared minus x squared plus 2hx plus h squared all over h is h tends to 0. Then x squared minus x squared there is 0. We remain with limit as h tends to 0 of 2hx plus h squared all over h. Then we have the limit is h tends to 0. We factor out h there. We have h 2x plus h all over h. Then this h goes. We remain with the limit is h tends to 0 of 2x plus h. Then if we say the limit is h tends to 0, we are simply saying as we make our h as small as possible, as it goes nearer to 0, then it means this becomes a 0. So we substitute our h there with 0. So we remain with 2x plus 0, and this becomes 2. This becomes 2x. So this is our limit of f of x plus h minus f of x all over h is h tends to 0. So we can simply see that it exists. So if it exists, then the function is differentiable at x, and this is our d f of x, our derivative. Thank you.